Good morning, Year 5. Okay, so today we're going to be looking at building on our knowledge of equivalent fractions. Yesterday, we had a look at some circles that were split into fractions, and you were matching them up and then working out what the equivalent fraction was. Today, we're going to look at moving that forward and creating a rule to find equivalent fractions. So, just a quick recap on yesterday. Remember, equivalent just means equal or the same. So we're finding fractions that are equal to each other. Yesterday when we looked at the chocolate, okay, all three children that were going to get some chocolate were going to get the same amount of chocolate, but that was recorded as a different fraction. So we had a half, we had 6/12, and we had 3/6. Okay, so all of those different parts, different fractions, led to the same amount. So your work yesterday looked like this. So let's have a look at what you were doing yesterday. So in this first fraction, we were going to count the denominator, what the denominator was going to be. So let's work out what the denominator is by counting how many equal parts the shape is split into. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I know my denominator is going to be 16. Okay, then the shaded parts, the parts that I'm looking at, 2. So this is showing 2/16. 16 parts all together, we're looking at 2 of them. Now, how do I make this look the same? So I'm going to have to colour in one of these sections here, okay, and I'm going to write my fraction. I know I'm going to be writing 1, 2, 3, 4, 5, 6, 7, 8. I'm going to be looking at eighths this time. And how many have I got shaded in? 1. So I now know that 2/16 is the same as 1/8. Okay, we've got the same size piece. Look. Now move on to the next one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our denominator is going to be 12. How many pieces are we looking at this time? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're looking at 10/12 being represented by that picture there. So let's make this the same. We'll be colouring all of the sections apart from that top one. A bit like a Pac-Man in there today. And we were looking at 1, 2, 3, 4, 5, 6. So sixths. And we have 1, 2, 3, 4, 5 shaded. So we now know that 10/12 is equivalent to the same as 5/6. So let's just take this a little bit further. Let's take one of our fraction pairs from here and think about how we could write this out. So let's have a look at 1/8 is equal to 2/16. So we've taken this one here. Okay. Now, what do we have to do to 8 to get to 16? 8 times 2 is 16. Now we're only ever going to be using multiplication and division here. Okay, we can't use addition and subtraction. It doesn't work. So multiplication or division. So 8 times 2 is 16. Now if we've done that to the bottom, okay, then we need to do that to the numerator too. So we've done it to the denominator. Does that work? 1 times 2 equals 2. So the important part is we have to do the same to the numerator and the denominator every single time. Okay, so whatever we do to the numerator, we have to do to the denominator, or the other way around. Now it can work both ways. So that was a multiplication way. If we were looking at that calculation the other way, we had 2/16 equals 1/8. Okay, this time we would be looking at a division, wouldn't we? Dividing by 2. Okay, and then we have to do the same up here. Divide by Okay, let's have a look at that in a little bit more detail. So what we've got here, and this is how your work's going to be set out today. Okay, we've got something set out, and there's going to be a missing piece every time, so missing pieces. So this, to get to 1, what do we have to multiply 1 by to get to 7? 7. 1 times 7 equals 7. Okay, now if we've had to do that at the top, we know we're going to have to do that down the bottom. Okay, whatever we do to the numerator, we have to do to the denominator. So we're going to multiply by 7, then we can work out the denominator over here by following the calculation. 5 times 7 is 35. So we've now created an equivalent fraction. 1/5 is equivalent to 7/35. Okay? The important rule is whatever you do to the top, you have to do to the bottom. So let's have a look here. Whatever we're going to do to the numerator, we're going to have to do to the denominator. So from 3 to get to 1, what are we going to have to divide 3 by? 3, I've got 3. I need to divide it by 3, don't I? 3 divided by 3 equals 1. Now I know I'm going to have to do that to the bottom, to the denominator. So 6 divided by 3 is 2. Okay, our equivalent fraction works both ways. So even if we've not got an image to represent today, we have created a rule. So we're using multiplication or division, and we're looking to see the relationship between these, okay, using multiplication or division, and whatever you do to the numerator, you have to do to the denominator. Whatever you do to the denominator, you have to do to the numerator. So you're going to have a set of questions that look like this, okay, so look at the one that's going to be able to, so here you're going to have to do this one first, aren't you, the numerators, okay, 2 times something equals 6, and then do the same to the bottom, okay. Down here we're going to have to look at the denominators first. So we've got the denominator here, 3 times something equals 6, okay, exactly the same up here to find the numerator. So have a go at that today, and I will see you tomorrow back for some maths together. Okay, have a play around with those. There's also an extension, so if you fly through the first section, move on to the extension. Don't feel you have to do the extension, okay, but have a look at this. What mistake has Rosie made? I want you, okay, to really clearly explain your thinking with this today, using all of the knowledge that we've gained. Explain your thinking, what's happening in each of these.